All right, welcome everybody. Now we need to get into redundancy protocols. All right, so the lecture you're about to see is going to give you an explanation, all right, on HSRP, VRRP, and GLBP. All right, we're obviously going to be focusing the configurations on HSRP, that is Cisco's baby, right? It's been for the longest for certification purposes. But I'm going to give you added information, and we'll do comparison tables between the three redundancy protocols. All right, because redundancy is something that is needed in a network. But in the presentation, I talk about all that, so I'm not going to bore you to death. Let's just get into the presentation and start learning the importance and the different types of redundancy protocols that we can use. See you in there. Welcome back, everybody. Now we're going to get into redundancy protocols, because redundancy is needed in a network, or is it? And that's one of the questions that you ask yourself. Is redundancy needed in a network? Of course it is. Of course, it's not. It's required. If it's not, it should be. And if you're working in a network that's not having redundancy, well, you better say something. Okay. So these are protocols that do redundancy for us. Okay. But questions that we need to ask is, how fast can the failover happen? Meaning, if you're going out one gateway and that gateway fails, how quickly can the client switch over to the other router, right? That's their, that's the redundancy. How quickly can it fail over? Is it something that has to happen manually, or the protocol is going to handle it itself? So definitely it's not something you want done manually, so the protocol is going to handle it, but how quickly can it do it? Will the customer notice a big, wait, or will it be just a little bump in the road? How is the client aware to switch? How does that client device, know, right, that it has to switch over? Well, within the protocols, as we go over it and we start doing the lab, you'll see, because there's many things. Well, not many things. Every protocol has its own little method of doing things, but they're all pretty much the same. And the timers and all that's what's one of the things that we'll be talking about on these redundancy protocols that they use. So based on a hold timer, is how long it will, the other router will say, oh, I didn't get anything from the other router, he must have died, so let's switch the client over to our side, right? That's pretty much. But that's looking at, let's say, within our own subnet, all right, or within just one client subnet. What if the WAN link fails? The other side of the router. What happens then? How does it know? What would we do? Well, there's something that's called tracking, okay? And we'll talk about it, and we'll do it, okay, in the lab. That you can track an interface, and then that interface goes down, then most definitely we can go ahead and the same thing will happen, where you'll go to the other side. Okay, it'll switch over. It'll switch over to the other router to go that way. But hey, listen, you can get to my LAN, but you can't get to my WAN, so I'm going to send you back the other way, and then the other guy take care of what they need to take care of. So these are things that these redundancy protocols offer. Obviously, the first one is HSRP, Hot Standby Ready Protocol, right? HSRP. It's Cisco only, and it was created way back in 1994. Will this be a question? I don't have no idea. No, probably not. Now, what will be probably a question is, uses by default a hello timer of 3 seconds. That was way back in the day, okay? Of 3 seconds, and a hold down timer of 10 seconds. So that means that if you have two routers, they're Cisco routers, okay, and they're both running HSRP, after 3 seconds, it doesn't send anything. It's going to wait an additional second, right? Because it's a 10-second hold timer, because it's 3, 6, 9, and then it's going to say, okay, one more second. Okay, yeah, he's dead. So I'm going to take over, and traffic is going to go that way. That is what, and we'll see it in the lab, and that's how HSRP, or pretty much all of them, work that way. Okay. But again, the timers have changed nowadays where you can put them into milliseconds, right? Just to let you know, but don't go crazy because you can create a lot of overhead on the router, CPU usage, all that good stuff. Right now, way back in the day, since the default timer, hello timer, meaning, hey, I'm still alive, it's every 3 seconds, well, that wasn't fast enough, right? That was, wow, really? You got to wait that long? So what the IETF 5 years later created, VRP, okay? So that can go across vendors, yeah. And we got faster timers, hello second 1, and hey, every second, hey, I'm still here, hey, still here, hey, still here, hey, still here. And then the whole, then it holds it for 3 seconds. So if after 3 seconds it doesn't hear anything, boom, it switches over. Faster than HSRP. So everybody went running to VRP, right? Everybody went running over there. And they said, well, cross vendors, faster timers, it's better. But now HSRP is just as fast, so it doesn't really make a difference. Okay. So that's VRP. We also got GLBP. Okay. This is Cisco proprietary. All right. And it was created in 2005. Haha. Okay. But this will has load balancing, which I skipped out over those first 3 bullets, but this does have true load balancing in it. And you can see the little asterisk that I put there. The most common feature for load balancing that they use is round robin. Host dependent is based on MAC addresses, and then you can also use weighted again. And there's something just know that you're not going to configure, but you're going to just understand that GLBP is a true load balancing redundancy protocol because it has actual features and how you can create that load balancing. As you can see right here, host dependent, round robin, or weighted. Okay. It was created in 2005. HSRP allows active. Active is a standby active. GLBP though is active. So this particular protocol, GLBP, is active. HSRP is standby active, meaning one router is actively sending out, everybody's going to him, okay? While the other routers, based on priority numbers, we'll get into that, okay, are just on standby, okay? With GLBP, all routers are active, which is cool. And that's why you have load balancing, where normally is round robin and everybody takes a turn, okay? That's pretty much it. So summarizing this, to understand this, key points that you need to understand: HSRP, Cisco proprietary, active, standby, and is based on the priority numbers, okay? Default hello timer of 3 seconds, hold on timer of 10 seconds. That was way back in the day. And today's redundancy, in today's world, we all can go to milliseconds if we want to, okay? VRP is an industry standard, all right? You saw, and it's not, I know your book tells you that it's just like HSRP. No. Okay, now, if the book said it, go with what the book says. But if you do your research, okay, it's really the router that's acting as, giving, everybody's going to them. That is considered the master router. And all the other routers are considered the backup routers. All right, so yeah, okay, I can understand active standby, why they put it in your book in the table as the same as HSRP, but in reality is master backup. So hey, Laz, what do we answer? Answer is in the book, okay? Just so you know. It will be messed up if they actually tell you in the test, a multiple choice question, VRP is an active standby, master backup, active, or standby. That will be truly messed up. But I will still answer, I'll go with the answer in the book, and in your CCNA exam, I will put in the note that well, it could be, yes, it could be at a standby, but in reality, it's called a master backup. Put that in your note, little sentence. It says just that because Cisco will get that. Okay, because if you look that up, all right, you will see that it's called a master and backup. But hey, I can see where they mean active and standby. All right, so GLBP, Cisco proprietary again. That one is active. All its routers are active. It has a lot faster timers, all right, and allows for load balancing. The key here with GLBP, why would you want to use that, is load balancing. Load balancing. That is the only true. You can load balance with the other routing, with the other redundancy protocols, but you got to play with the priority numbers. So it's not really true load balancing. It's just like you're saying, okay, because the highest priority number becomes the active router. Then the second highest becomes the standby. Then if you want to, okay, so you'll be the first standby. We'll make the other router will make it a lower priority number. You'll be the second standby. And then the other one will be a lower priority number. You'll be the third standby. You can play around like that. But yeah, that's, keep track of all that. It's a pain in the butt. But I have used HSRP. Not that I've configured HSRP, but in the network that I was in telecommunications, they did have HSRP, and they did have an issue with it, and it wasn't a 5-minute fix. Maybe because it was telecommunications, and we're talking about a tremendously huge network where, like, I don't know, VPs and friggin' managers and technicians got together, and people that were in a department that specialized in this. It took 3 hours to fix. Okay, so there's not a 5-minute fix. We have small network, maybe. On enterprise network, no. Okay, so don't let nobody lie to you. With EIGRP, I put the RFC there for the IEEE. Just remember that number. It's in the book. Okay, remember that number. Okay, so they could be saying, what RFC belongs to? Why are you asking me this? Okay, it's not necessary. But hey, we're taking a test. So, okay, I'll remember the RFC. All right. So let's see here. We got that. That's what you need to know. So let's start breaking down HSRP. I said already, their gateways are organized into standby groups. Okay, the default standby group is 100. One is going to be active, which is the master router, but in HSRP is considered the active router, and the other one is the standby. So again, you can set the priority number. There's a default already, which is 100. Okay. But if you want to make it a bigger number and then let the other one get the default, that's fine. It's going to see it and it's going to create. But again, you'll see all this in the lab, how it gets one to be active and one to be standby. All right. And it does create a virtual router ID, which is the IP address, and a MAC address is generated. Now, the virtual IP, you decide what's going to be the virtual IP. All right. The virtual MAC address for HSRP is specific. And I broke it down for you. And you need to know this right here. You need to know the breakdown of that MAC address. All right. Now you see here, these are hexadecimal numbers. We should know this, right? This is 1, 2, 3, 4, 5, 6. Each one is 4 bits. 6 times 4 is 24 bits. So the first 24 bits is considered the Cisco vendor ID. Okay? The first 24 bits. The other, this is 4 times 4 is 16. The next 16 bits is considered the HSRP ID. And there it is right here. You're looking at it. And then whatever group number you create, the last 8 bits will be the standby group number you create. Okay? That is how it creates the virtual MAC. So you can see, whoa, sorry. How about that? So this would be group 1. Put on it. Okay? So just remember that. And you see here the 07 AC. Ooh. AC and 07. Okay, so know that. Know this breakdown. Guaranteed. I guarantee you they're going to ask you this. They've asked in the past. They're definitely going to ask it in this one. So keep this one in mind. Know this. period. 24 bits, 16 bits, 8 bits. All right. So the configuration of it, what do you do? Well, you got to go into the interface. All right. And there is no HSRP command. It's called the standby. So you go inside the interface. The interface already is going to have an IP address. All right. You say, well, the standby 1, right? The group, the IP is going to be 10.1.1.1. All right. Then the standby 1, that's the group, priority is 120. What was the default? 100. Oh, there it is right there. All right. And the range is 0 to 255. So again, the higher the priority number, you are the active router. So this one, 120, we're making it the active router. Now, preempt, what does that mean? Preemption means that if for whatever reason you go down, right, the other router, which is standby, that has a lower priority number than you do, he is going to become the active router. But when you come back, you want your job back. You want to be the active router again. So I love this definition right on the router, and you'll see it. All right. Preemption says overthrow lower priority router. So when you come back, if somebody else has a lower priority number than you, then you'll take their job away, and you will be once again the active router. All right. So that's what preemption does. Now we said about the WAN. What happens if the WAN, something happens to it? Okay. How does it going to know? Well, we track. We go standby 1. You always got to put the standby 1 because that's the group that we're in. And we're going to track the fast Ethernet 1. In this case, that's the WAN side, the other side of the router. We're going to track it. And really what that does is it's going to lower. You can, in the packet tracer, it won't allow you, it'll decrement your priority number. The packet tracer does it, it decrements it by 10 by default. All right, but you can actually, in a real iOS, you can put in how much you want to decrement, how much you want to subtract from what you have right now. All right, so you become a standby router, and the other ones become active routers. So you will actually have a lower priority than the other routers. Okay, that's how that works. So you have the standby 1, which that already is creating your group, and you give it the virtual IP, you give it the priority number. Okay. You set the preemption in case you lose, connectivity to whatever issue, cabling, what have you. And when you come back up, you can overthrow all the lower priority numbers. And you're also tracking the other side of the router just in case it goes down. And you can put a decrement, 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 and you can put a number, and it'll subtract it from your priority number. All right. So you can become a standby router, and the other one will take over. That's how that works. Now, the timers, you see here, I put it in there. Standby 1 timers, milliseconds. You can put milliseconds in there if you want to. But I put it, processor cycles, be careful. Oh, I mean, come on. I know how it is. We want things to happen in a blink of an eye. I mean, I always use the example of the elevator, all right, where you press the button, you wait 10 seconds, press it again. You wait 3 seconds, you press it again. It's like, look, it knows it's coming. All right, just wait. Okay, or somebody's holding it, and no matter how many times you press that button, it ain't gonna come until they take the box out of the way, until they get out of the way. It's not gonna come down. All right, so don't go crazy changing these timers that you want to have to happen so fast that you're gonna, create a lot of overhead on the router. You do not want that. You do not want that. Okay. As far as the client configuration, basically, they just need to know which is your virtual IP address, which is going to be the gateway for the clients. All right. So they'll have that virtual IP because that VIP or that VIP, it's going to go on every router. It's good when you create your active or standby routers, that virtual IP address will be on every router. So if you have that virtual IP as your gateway, then any one of those routers can be your gateway. All right. And then once the active goes down, it just switches you to the other one. It has the same VIP. So boom, you're going that way. You already have it set. Because imagine in a network that you don't have that and you don't have physical redundancy, period. Okay. where you can just route one to another way. Then it's like, whoops, hey, can you go over there please and change your gateway address? You're not going to do that. So you have a virtual gateway address, all right? That's the virtual IP address, or the ghost IP address as they call it. So once the active router goes down, it will, after 10 seconds, right? It'll switch over to the other one. It really is not going to take that long. You'll see it'll take a couple of request timeouts, and boom, and then it goes to the other one. All right, but we'll see it when we get to the lab. Just a little bit more information, little comparison table. All right. So when we compare the three redundancy protocols, who's Cisco proprietary? HSRP and GLBP. Those are the only two. VRP is not Cisco proprietary, is the IEEE. All right. And then we go, okay, an interface IP address can act as a virtual IP address. On HSRP, no. On VRP, yeah. On GLBP, no. So you cannot use in HSRP the IP address on the interface as your virtual IP address. It has to be something else. Okay? It has to be something else. All right, so more than one router in a group can simultaneously forward traffic for that group. Only GLBP can do that because it has the active router. It has the load balancing, so it will send it to multiple routers within that group, because it does create multiple MAC addresses as well, virtual MAC addresses as well. Okay, the only true load balancing protocol. And you can see there the hello default timers, and this is old, really. 3 seconds. Even the book says the same thing: 3 seconds, 1 second, 3 seconds. All right, and then you have the hold down timers. Not the hello, but the hold down. It's 10 seconds, 3 seconds, 10 seconds. Now I showed you can use milliseconds. Okay, so again, credential enabled by default? No. For HSRP, you have to do that yourself. And VRP, yes, it's disabled by default. Great. But for GLBP, what's AVG is active virtual gateways. Okay, it's not on by default. You would need to configure them. But for active virtual forwarders, which will be on your active router or your master router, okay, because they're all active. Well, one's got to be the main one. But anyway, so they'll have active virtual forwarders. All right, that is on by default, but not the active virtual gateways, which is your MAC address. All right, and to continue the comparison table, the default priority for all of them is 100. So you can just change that. What about weight? No, only GLBP uses weight. I showed you that. True load balancing. We will have to play with HSRP and VRP on their priority numbers. Authentication supported across the board. And here's where it gets fun. All right, if they get down to this, but hey, it's a 102 question test, no configuration, so why not mess with you? All right, authentication supported across the board. Well, I said that right, I'm sorry. Multicast address for HSRP, 224, 18, 224, 102. So HSRP 2, VRP 18, GLBP 102. Do yourself a favor, memorize these things, please. Okay. Now this would be just way too much. All right. Now I did give you already the one for HSRP, which is really the one you need to memorize. If they make you memorize the VRP and GLBP, I'm so sorry. Okay. But again, here they are. If you got space in that gray matter, do it to it. And there's your breakdown for your for the group and your active virtual forwarders as well for HSRP. Okay. But again, you don't have to worry about. I don't think you have to worry about these right here, like this one or this one or even this one. But definitely worry about the one that I told you before, which is the virtual MAC address for HSRP, because that is Cisco's baby. All right. So with that said, that's the end of this lecture. So what we're going to do next is go into the lab and take our time and configure HSRP. I'll see you there.